Hi, future doctors. Welcome to the next class. So, we were discussing about force. How many forces are going to act on an object which is placed on horizontal surface? So, if you're standing, or if you're sitting, if you're placing any object of mass m on the surface, so on all of us, gravitational force is acting downwards. Actually, we should move like this, but the surface is going to act, result into acting force in upward direction. This one only we will say. In some books they will write R, in some books they will write N. Whenever object is at rest, this N is going to be equal to mg. So if you are taking any object here, so let us assume you are taking an object here like this. So this weight is going to act downwards. My hand is applying reactant force in upward direction. If you are keeping more objects on my hand, then what will happen? My hand will move downwards. Then it is not at rest position at that time. So if you're standing like this on the surface of the earth, all of us at rest position because our weight is going to act downwards. So earth surface is going to act reactant force upwards. N equal to mg divided. Same object if we suspended by string, what will happen? Again, its weight is acting downwards. Within this string, what will develop? Tensional force is going to be developed. If both are equal and opposite, then only it will be at rest position. Let us assume if weight is more, then string is going to cut, object will fall downwards. So if you cut the string, object is falling downwards. Let us assume. How much force is acting on the object now? F equal to mg. Now what is the acceleration of the object according to Newton's second law? So ma equal to mg, therefore a equal to g. This type of questions they will ask. When the string is cut, so with how much acceleration object is going to move. So now t equal to mg. Like that, object may be suspended by spring also. So on the horizontal surface, weight, gravitational force is balanced by normal reaction. So when object is suspended by string, gravitational force is developed by tensional force developed in the string whenever it is at rest. Now, object is suspended by spring. Now, the force developed in the spring we will call restoring force. Now, this restoring force will balance this mg. Correct? So, this is about different forces, how those are going to act on a body. Now, we will see a metal plate is going to be placed. So, this metal plate mass is going to be capital M. So why we discussed all this means on this metal plate, gravitational force is going to act downwards. So if you're taking this plate on your hand, it will be at rest. If you remove your hand, it will fall downwards. After removing also, it should be at rest means in which direction we have to apply force? In upward direction. In upward direction, how we are going to apply force means they will fire some number of bullets they will give. So whenever they are firing bullets, so they are embedded into the plate they will give. Embedded means they are sticking with the metal plate. How many number of bullets should be fired to keep this metal plate balanced or at rest position they will ask. So at the time these bullets are firing with velocity u. So they are embedding or they are embedded into the metal plate or they fix it within the metal plate. At the time final velocity is zero, initial velocity is u. Then what is the change in momentum we are going to get? Final momentum minus initial one. Final momentum is zero. Therefore, change in momentum is going to be mu. Then how much force is going to act? dp by dt. mu by t. This is for one bullet. For n number of bullets, you should multiply with n. So, n mu by t should be equal to, this is force applied by number of bullets capital M, should be equal to mg. Therefore, number of bullets per second is going to be capital mg by mu. What is capital M here? Mass of the metal plate. Small m is mass of the bullet. Next, same case, they will give after hitting the bullets, they are going to return from the metal plate. Then how much force? Now, this is the metal plate. They are hitting with velocity u with the same velocity. Those are returning. Let us see. If different velocity means that one also fine. If same velocity, u and u both are equal and opposite, we are saying. At that time, what we got change in momentum. So change in momentum already we discussed in previous class, 2mu. Therefore, now time. Force we are going to get dp by dt. So 2mu by t for one bullet. For n bullets, n into 2mu by t. This force should be equal to weight of the metal plate. Now, number of bullets per second. So mg by 2mu. See the difference? Here, whenever embedded, here there is no 2. Here embedded means returning back means 2. Let us assume both are going with different velocities. Hitting velocity u, returning velocity v. Then what is the change in momentum you will get? So already we discussed this one also. So if it is u, if it is v. So both are different means equal and opposite. Therefore change in momentum is v plus u. V plus u. Then force if you want to get means m into v plus u by t. This should be equal to mg. Isn't it? For n number of bullets, this should be multiplied with capital N. So like this, you have to solve whenever they're asking what is the force or number of bullets to fire from the gun to keep the metal plate is going to be balanced. Next, if water is coming out of the jet, if you're taking fire engine, so from that nozzle, if water is coming outside with how much force? If this water is going to hit a person, person is going to be moved. Means some amount of force is going to act. How much force acting on this person? Isn't it? So water is coming with velocity v. They're going to ask how much force acting. So again we should calculate force is equal to. Now here what is going to be constant? It is moving. Water is going to move with constant velocity. Constant velocity means our formula v is equal to dm by dt. So you can take water bottle. So after removing water bottle cap, if you pour water, water is coming from this area. Otherwise, some water bottle may have nozzle like this. So the water which is coming out of this nozzle is different. Out of this nozzle is different. It is depending on area of cross section and with what velocity is going to come, and the mass of water coming out of this area is different. This area is different. So how much mass of water is coming with respect to time we have to calculate. For that, density rho is equal to mass per unit volume. So mass is equal to density into volume. So what is the volume here? Area into length. So area into length. So substitute. So F is equal to V d by dt of what we can write here? Rho A L. So V into rho A. What is dl by dt? So what is dl by dt? So this is water is changing its length with respect to time. This is only velocity. Therefore, V into rho A into V. That is nothing but rho A V square. So F is equal to rho A V square. How much force is acting? If you are taking oil in this, density is going to be different for oil. With what velocity it is coming, what is the area of cross section? If you are taking kerosene, how much force is going to act? If you are taking petrol, how much force is going to act? If you are taking water, how much force is going to act? So F equal to rho A V square. So this formula you should remember whenever it is coming out of the nozzle area with some velocity, how much force is going to act. So same like this, they will ask power. What is the power of this water? Power formula we came to know in terms of force and velocity, FV. So force already we got rho A V square into V. Therefore, rho A V cube. This is nothing but power. So P is nothing but power. So this force equation we wrote in terms of velocity and dm by dt. So previously we discussed force equation in terms of change in momentum. So MEA also. So M into dV by dt, another formula, M into what is A? V into dV by dx. So all these are the different formulas for force. So you should remember all this. I hope you people understood. So this is the force exerted by liquid which is coming out of this area with velocity v. Okay. So next we will meet in next class to discuss to result in force and equilibrium condition of the force. Okay. Thank you.